All right, we are an hour and a half later again. The turn on time was 2:30 when we started this new design, and then it was, rock is warm on the bottom. Then it was 4 o'clock, and now we're at 5:30, and our sun is, we lose our sun at about 6 o'clock up here. So as you can probably see, we got good steam coming off. This is nice and warm. Woo! Dropping water down in there. Let's see what temperature this lid is. I'm reading 33, 37, 28. Container is, holy cow, 71 degrees on the outside of the plastic. The container, 44 on that side. Lots of water dripping off that lid. All right, our goop, the gasket maker, is only so good. 181, 200 and some degrees, 86, 62. Again, surface temperature. As soon as you open that lid, you lose a lot of heat, and we're I think we're about -4 right now. Let's see what a rock says. That says +12. That's wrong. Let's see what's behind there. 0 degrees on those rocks behind the solar panel. So, and the sand, the exterior of my wall, yeah, 0. So we're flat on 0. Yeah, she's warm. Ooh, yeah. So this bin, when it's done, it's going to go into the chicken coop tonight. It's going to let it radiate heat. That loses temperature so fast. 55, 81. Yeah, so as soon as you dig that sand back, you just lose your temperature. Which I'm trying not to get it on there. I don't want it on the top. So don't bury your tip. If you haven't seen a previous video of attempt number 1 blunder, I ended up burying the entire element in there, and the plastic molding that was around the terminal connections had melted, crumbled, and fell apart. There's the chunks of it actually right there. So I ended up using automotive 600 degree Fahrenheit, 316 degrees Celsius gasket maker, and it's staying on the top of the terminals nicely, but it is kind of gooping a little bit. It didn't go all the way down to that bottom corner there. You can see the metal. So not too bad. It's definitely better than the plastic, but I didn't bury it underneath all the sand either, and just totally captured it in the system. Let's check the temperature on the, again, if you didn't see the previous video, I left a little bit of a steam release for the, there we go. Actually, maybe I'll do it here. Yeah, that captures it as soon as I close it up. There we go. So yeah, if you didn't see the previous videos, I let it have a little bit of a air release. So because my sand is wet, that's not the recommended deal. Should have dry sand, but they dug it out of a wet bin. All right, let's check the fuse temperature. We are, oh yeah, 0 degrees, just like the air temperature. The switch, 23, 23. 0, 0. Yeah, she's all right. So that's all. Yeah, nothing going on there. Okay, so wires are holding out beautifully. Again, this is like, yeah, 4 to 10 amps of draw depending. It showed, the earlier test showed 10.2 amps of draw going through, which gets me questioning how to do some more calculations, because basically you take the resistance of the element to 10.8 ohms, and you divide that into the 48 volts that this panel creates, and you basically get I think it was 4.44 amps is what it was supposed to draw. But when I tested the element on top and going through one side to the other, after feeding through, it read 10.2. And that's basically what the solar panel could output. So I got some calculations. I'm no electrician in that method to understand that 100%, but regardless, there you go. So whatever your output is I think what they will be pushed through the element. And if we take that 12 volts, sorry, if it is flowing 10 amps at 48 volts, that's 480 watts, which this element is a 1500 watt capable. So we're only 1/3 of the way out of the way there, so it's should be doing just fine. And obviously it's heating the sand. So yeah, once the sun goes away, this bucket's going to be moved into the chicken coop, and it can just radiate heat off into their zone and keep the assist the electric element, because right now we're running 120 into the coop on a 150 watt panel and 2 ceramic bulbs or heating elements that go in the light bulb socket. So when it draws heavy in minus 35, we were pulling 9 kilowatts on a full day, 24 hours, which I don't want to be pulling that, because as I've said, of building up a solar system, I got to reduce my power draw on birds, and birds don't need it, but the eggs and the water, we got to figure ways to do that. So this will be designed, I'm going to build a box out of sand to heat the egg bed, and then another one for the water bed, and hopefully they'll maintain that temperature to build it big enough to carry the temperature through the night until the next day that solar will recharge the sand. If I get a couple days of heat, I'll need a big sand bed to do that. So it's all testing, and small first and just upscale it from there. So eventually run the whole coop, and potentially garage heating and stuff too. So we'll see. I'm going to be doing lots with this. All right.